Good morning, students. Now we finished the analog communication so far, and in that analog communication then you will see the complete modulation technique and demodulation process, all these things. Okay, but now we are at the digital communication. Then you know how that analog signal will be converted into a sequence of ones and zeros. Okay, and what are the different types of techniques to convert an analog signal to digital signals, and what are the different kinds of techniques in the digital process which we are already covered. Okay, so now what is the procedure? This is the analog signal. Now this analog signal, first you are doing a sampling, right? Sampling, and next one is, what is next one? Quantization, and the next one is encoding. You know that the output of the encoder is a sequence of ones and zeros, rectangular pulses. Right? Now this is so far what we are completed: sampling and quantization, encoding. What are the different types of technique, PCM, DPCM, all these things which we are finished. Okay. So now this is a message signal, which is an analog signal, continuous wave signal, which is a low frequency signal, right? Which is a low frequency information. Now with the process of this sampling, quantization and encoding, what happen? Nothing will happen. This analog signal, this continuous in amplitude, continuous in time signal will be converted to binary data, a sequence of ones and zeros. Am I not? But this is also a message signal in the form of bits, right? In the form of bits. But this is also a low frequency signal. Am I not? This is a low frequency information, but in terms of bits. So now what is the problem with the low frequency? You know that. Now this low frequency information which cannot transmit it for longer distance, and this binary data and this rectangular pulses, which is the low frequency information and which cannot transmit it through the free space directly, which is not possible to transmit this free space directly, because this is the low frequency information, which is a low frequency. If you transmit as it is, you know, the antenna height requirement is very high. Practically it is not possible to design an antenna of that much height. Therefore this is the problem with the low frequency information, and this rectangular pulses cannot transmit it directly into the free space, because that is a low frequency information. So what should we do? To transmit any low frequency information, whether it is an analog or digital, whatever it may be, then we require to take the help of a signal can able to transmit this particular information. Now that signal, which we are call it as, or it as a carrier signal or not? Yes. Now when we are taking, now that process is called as modulation, right? We'll take the help of the carrier is nothing but modulation. Now I take the help of an analog carrier here. Which carrier? Analog carrier. What are the characteristic parameters of the analog carrier? Amplitude, AC, peak amplitude, frequency is FC, and phase is phi. This is the characteristics of analog signal: amplitude, frequency, phase. Am I not? Now what happened? Now whenever the modulation is nothing but, what is the definition of modulation? Okay, because you can completely study the overview of the modulation, type of modulation, why modulation, what is the use of modulation, all these things you are knowing, right? So modulation is nothing but any one of the carrier characteristic parameters are changed, then the modulation will taking place. Okay, before modulation these are the carrier characteristic parameters, but after modulation any one of these three parameters are changed, then the modulation will be completed, right? Now, let us assume, for example, when the modulation is done. If the modulation is done, now this is a message signal information, but this is now binary data, right? Now this is your binary data, binary information now. Now, one of the carrier characteristic parameters are amplitude. If amplitude of the carrier is varied in accordance with this binary data, if the amplitude of the carrier is varied in accordance with this binary data, the amplitude of the carrier is varied in accordance with this binary data, then that modulation technique is called as amplitude shift keying. Amplitude shift keying. Okay, what is that? Amplitude shift keying. Similar to amplitude modulation. Okay, so for better understanding, if any one of the carrier characteristic parameter, one of the carrier characteristic parameter is frequency, if the frequency of the carrier is changed in accordance with this binary data, then this modulation technique is called as frequency shift keying. And one of the carrier characteristic parameters are phase. If the phase of the carrier is varied in accordance with this binary data, then that modulation technique is called as phase shift keying. Okay, this is similar to AM, this is similar to FM, this is similar to PM. Okay, but this is in other, those are in analog, but this is in digital communication, right? Now these are the modulation technique. Now this is after modulation. Now this is the modulated signal, am I not? Now this is the modulated signal, whether it is ASK or FSK or PSK, but now the modulation process is involved the analog carrier, right? But this is the low frequency information, but when carrier comes into picture, then after modulation, then that is a modulated signal. A modulated signal is nothing but a range of frequencies, a band of frequencies. Now that's why this is called as band pass data transmission. A band of frequencies are available here. This is a band pass data transmission, and we can say in another way. Now these are the actual modulation, but the students are, most of you are thinking that, sir, sampling, quantization, encoding means PCM. What is PCM? Pulse code modulation. So students are thinking that itself is a modulation technique. No, pulse code modulation, differential pulse code modulation, delta modulation, adaptive delta modulation are not the actual modulation techniques. There the word modulation is using because some parameters are changing, right? Some parameters are changing, therefore use the word modulation. But exact modulation means the carrier should take the information signal. The information should transmit from one point to another point. So that is the modulation. The information, how it will transmit from one point to another point, definitely you need to take the help of a high frequency signal, because the information is nothing but a low frequency signal, whether it is analog form or a digital form. Okay. So whenever the actual carrier comes into the picture, then only we call it as an actual modulation. So this is the actual modulation, not PCM, not DPCM, not delta modulation, not adaptive delta modulations, are not the actual modulation technique. Now those techniques are converting an analog signal to a sequence of ones and zeros in a different process. Okay. Now that ones and zeros alone cannot transmit without carrier. That ones and zeros can able to transmit from one point to another point with the help of carrier. Then this is the modulation process. So this is the actual modulation in a digital communication system. So we also call it this as digital modulation techniques. Okay, this is the actual digital modulation technique. Okay, so this is the actually band pass data transmission, but this is nothing but the actual modulation in a digital communication system. So this is called as a digital modulation techniques. Okay, this is a digital modulation techniques. Now, data is digital. Modulation is done with the help of analog carrier. Digital analog carrier modulation techniques in another way, okay? But the best one is digital modulation techniques. This is the actual digital modulation techniques. Now from here, we will start from ASK. Now we will continue the digital modulation techniques continuously. We will continue the digital modulation techniques, okay? Now, I hope you understand this diagram. Then you can easily understand these three and remaining all digital modulation techniques, okay? No doubt. కనపడుతుందా మర్చిపో okay. Now this is the digital modulation technique. Then we will see one by one, okay. Now, what is amplitude shift key? First you tell me. ASK. Amplitude shift keying. See, the word actually keying is nothing but sending, okay. That you can understand easily. Now, sending, so he is transmitting, right, ones and zeros. 1 0 1 0 means only 1 and 0, okay. So keying is nothing but sending for 1 for 0, okay. What is 1, what is 0? 1 what it will be sending, 0 what it will be sending, we will see, okay. Keying is nothing but sending, okay, or the process of sending ones and zeros is called also keying, okay. So what is amplitude shift keying? First you tell me the definition. Note on the definition. Amplitude of the analog carrier, because here we are using analog carrier as a we are using analog signal as a modulated carrier, okay. So amplitude of the carrier is varied in accordance with binary data is called as amplitude shift keying, okay. Once again I repeat, amplitude of the carrier is varied in accordance with binary data is called as amplitude shift keying. Now what is ASK? Where is binary data? Now see here. Now this is the binary data 1. Take some sequence binary rate 1 0 1 0 or 1 0 1, whatever you want, okay. So this is the binary data. Now see here, I explain the modulators also, okay. Now this is the message signal, which is nothing but a binary data, right, binary data. To generate an ASK signal, okay, to generate an amplitude shift keying signal, the binary data is represented in on-off signaling scheme. The binary data is represented in on-off signaling scheme. What is on-off signaling scheme? The on-off signaling scheme is nothing but for binary 1 it is positive voltage, for binary 0 it is 0 volts, okay. For better understanding, for simple calculations, this positive voltage I can treat it as 1 volt, okay. It's not a 1 volt, it may be 5 volts or 10 volts or whatever it may, it depends upon the application. But for easy calculation process, I just take positive voltage as 1 volt and binary 0 is 0 volts. So this form is called as on-off signaling. Okay, the binary data is represented in on-off signaling to generate an ASK signal. Okay, right. Now this is the binary data. Alone cannot transmit it. Therefore, will take the help of a carrier. Now what is a carrier? Now first we'll do this one. So binary data is represented in on-off signaling. What is on-off signaling? Binary one means positive voltage, right? Binary 1 means positive voltage. Binary 0 means 0 volts. This is the positive voltage 1 volt. This is the 0 volt. But each bit is having a duration of TB seconds. This is 0. TB, bit duration is TB. Okay, this is very, very important. Now each bit is having a duration of TB. Okay, I just explained for binary 1 and binary 0. You can do it now. 1 0 1 0 1, whatever, how much you want, you can do it. But binary 1 is positive voltage, binary 0 is 0 volts. Okay, this is the ground voltage line. Next, now with the help of carrier. Okay, now this transmit. Now this alone cannot transmit it. Therefore, this will take the help of analog carrier. AC cos 2 pi FCT. Peak amplitude is AC, carrier. Now this is the carrier signal. Peak amplitude of the carrier is AC. Minimum amplitude of the carrier is minus AC. Peak to peak amplitude of the carrier is 2AC. Peak amplitude of the carrier is AC. Minimum amplitude of the carrier is minus AC. Peak to peak amplitude of the carrier is 2AC. And frequency is FC. And phase is some phi. This is the analog carrier. Okay. Now see here. Now this is the multiplier. Now you tell me. AC cos 2 pi FCT multiplied with 1 volt. AC cos 2 pi FCT multiplied with plus 1 volt means AC cos 2 pi FCT. This is the modulated signal. What is S1 of t? S1 of t, which is nothing but message signal, carrier signal. The message and carrier multiplication is nothing but modulation. S1 of t is AC cos 2 pi FCT. Now, AC cos 2 pi FCT multiplied with 0. So what is that? 0 volts. This is S2 of t, which is equal to 0 volts. So this is nothing but modulated signal. Now we'll see. Okay, first we'll write here. Now see here. AC cos 2 pi FCT multiplied with plus 1 volt. So here it is AC cos 2 pi FCT. Now AC cos 2 pi FCT multiplied with 0 volts. Therefore, this is 0 volts. Now AC cos 2 pi FCT. Now this is S1 of t is AC cos 2 pi FCT. This is S2 of t, 0 volts. Okay. Now this is see here, amplitude of the carrier before modulation is constant, right? But what is the amplitude of the carrier after modulation? The amplitude of the carrier after modulation is changing, right? Now here it is AC, but here it is 0 volts, right? So this is nothing but, what is this? This is nothing but an amplitude shift keying signal. This is nothing but an ASK signal, amplitude shift keying signal, modulated signal. Now this is the ASK signal in time domain. This is the amplitude shift keying signal. This is the ASK signal in time domain. This is the mathematical time domain equations of ASK signal. Is it correct or not? Now this is the amplitude shift keying modulated signal for binary 1 AC cos 2 velocity, for binary 0 which is equal to 0 volts. Right? For S1 of t is AC cos 2 velocity, S2 of t is 0. Again this is binary 1, S1 of t, again binary 0, 0 volts. Therefore, the amplitude of the carrier is changing in accordance with the binary data. Now this is called as the amplitude shift keying, okay, ASK signal. This is the ASK waveforms in time domain, and this is the ASK modulator, or we call it as ASK transmitter. This is ASK transmitter or ASK modulator. Okay, now this is the ASK modulator or ASK transmitter. Then we will see the demodulation process. Now see here. Now output of the transmitter is a modulated signal, and input to the receiver is also a modulated signal. Now this is the receiving is an ASK signal. Input to the receiver is nothing but an ASK signal. Right? Whether it is S1 of t or S2 of t. Now again, this is also a multiplayer. One input is an ASK signal, which means whether it is S1 of t or S2 of t. Now another input to this multiplayer is a local oscillator. Can you see any somewhere this one? Now another input is a local oscillator. Now this local oscillator will generate the same frequency and same phase of the carrier which is used at the transmitting side. Now this is AC cos 2 pi FCT. Now this type of demodulation process is called as, in analog, if you use the same frequency, same phase of the carrier generated by using local oscillator, now that demodulation process is called as synchronous detector, right? Now that is in analog communication we call it as synchronous detector, and digital communication this is called as coherent detector. What is this? Coherent detector, which is similar to synchronous detector. Okay, this is the coherence between the carriers. Okay, synchronization between the carriers. Coherent detector. This is called as coherent detector. Okay. Anyway, we'll see. Okay, this is a synchronous detector in analog. Digital, we name it as coherent detector. So now, what is output of the multiplier? Let us see here. The output of the multiplier is the output of multiplier at the receiver is, what is at the receiver? S1 of t multiplied with AC cos 2 pi FCT. Now which is nothing but, what is S1 of t? S1 of t is nothing but AC cos 2 pi FCT, AC cos 2 pi FCT. AC cos 2 pi FCT multiplied with AC cos 2 pi FCT. Now which is nothing but AC square by 2 plus AC square by 2 into cos 2 pi into 2FC into t. Now this cos into cos is cos square. Cos square theta can be written as 1 plus cos 2 theta by 2. Okay, this one. Okay. Now this is ASK demodulator or ASK receiver. This is the local oscillator AC cos 2 pi, same frequency, same phase. Now this is nothing but ASK. This is ASK receiver, or we call it as ASK demodulator. Now this is the output of the multiplier AC square by 2 cos 2 pi into 2FC into T. But we want the output of the demodulator is a low frequency information signal. Okay, so we'll kept a low pass filter here. The low pass filter will not allow this high frequency term. Then the output of the low pass filter is AC square by 2. What is AC square by 2? Is a positive voltage. Am I not? Now for S1, this is for S1 of t. For S1 of t you can get. Now this is for S1 of t. For S1 of t is the input to the demodulator. Output of the demodulator is positive voltage plus AC square by 2. Now where is that? Now see here. For S1 of t, now this is plus AC square by 2. S1 of t, this is plus AC square by 2 is a positive voltage. Now for S2 of t, now for S2 of t, what is there S2 of t? S2 of t is nothing but 0 volts. S2 of t is 0 volts. Now this is S2 of t multiplied with AC cos 2 pi FCT. But what is S2 of t? 0 volts multiplied with AC cos 2 pi FCT. Now which is nothing but what? Which is nothing but 0 volts. So this is a 0 volts which is a DC. This is 0 volts for S2 of t. Now for S2 of t, the output of the demodulator is a 0 volts. Right? Again, if it is S1 of t plus AC square by 2, S2 of t 0 volts. So if you see, this is the output of the demodulator. Now this is output of, see here, this is output of demodulator. Now what is output of demodulator? The output of the demodulator is a binary 1, binary 0. The output of the demodulator is a binary 1, binary 0. And what is the transmitted signal? A binary 1 and binary 0. We'll be getting or not. So this is the ASK signal output of the transmitter, and this is the output of the demodulator is your original binary information. Okay. Now this is the amplitude shift keying signal time domain. Now this is the ASK transmitter or ASK modulator. This is the ASK transmitter or ASK modulator, and this is ASK receiver or ASK demodulator, and we practically named as coherent detector. This is ASK transmitter or modulator. Okay, no doubt. Okay, So this is ASK in time domain, ASK modulator, ASK demodulator. Okay. So what should we do? But between this transmitter and receiver, one more block is also there. What is that? Channel. Transmitter, channel, receiver. Don't write transmitter, receiver. Channel is. Now my question is, what should be the channel bandwidth? Now how much channel bandwidth is required to transmit this ASK signal? Okay. So that we can decide it only when how much is the bandwidth occupied by an ASK signal. What is the bandwidth of amplitude modulated signal? If any message signal is modulated by an amplitude modulation, then the bandwidth required is 2 omega. DSB means 2 omega. SSB means omega, right? Now FM means 2 into beta plus 1 into FM. Now similarly, how much bandwidth required to transmit an ASK signal is known to us, then we can easily identify how much should be the channel bandwidth we can utilize to transmit this signal. Okay. Now we'll see the bandwidth of ASK signal, but now this is the time domain signal, ASK signal in time domain, but I want a ASK signal in frequency domain in order to find the bandwidth, because in a previous analog sessions which we are already calculated bandwidth of this. Now see here, that's what every time I am asking you to write. Duration, bit duration is important, TB, TB. Each bit will spend a time of TB. See here, this is a message signal, right? Sorry, here this is the message signal, which is a low frequency information, which is a rectangular pulses, a significant low frequency components. Okay. So now this is the binary data, a pulse width of TB seconds. Am I not? Now this is the binary data, a rectangular pulse of pulse width how much? TB seconds. You know that if a rectangular pulse whose pulse width is TB seconds, now what is the Fourier transform? What is the spectrum? The Fourier transform of rectangular pulse is nothing but a sinc function. Is it right or not? Now a Fourier transform of rectangular pulse, the first problem in analog communication. The Fourier transform of rectangular pulse is sinc. Now the rectangular pulse bandwidth is inversely proportional to pulse width. You know the derivation part and everything with you. Now this is the Fourier transform of a rectangular pulse M of t spectrum M of f, because here binary 1 is nothing but this binary 1 is nothing but a rectangular pulse of pulse width TB. So whose spectrum is sinc function and a bandwidth is 1 by TB. But this is the binary data. I am not asking about a bandwidth of binary data. I am asking a bandwidth of an ASK signal. What is the amplitude shift keying modulated signal in frequency domain? I want an ASK signal in frequency domain. Show me the ASK spectrum of ASK signal. Now very simple. What is a modulation? There are two definitions of modulation. Remember these two definitions n number of times. So modulation is nothing but any one of the carrier characteristic parameters are changed in time domain. That is the definition in time domain. If carrier characteristic parameters are changed, is called as modulation. That is the modulation definition in time domain. But I am giving another definition of modulation. Now the low frequency information spectrum is transformed to high frequency is called as modulation, but this modulation definition is in frequency domain. Now see here, the spectrum is available as it is, but this spectrum is shifted right side, left side by an amount of, what is the carrier frequency? The carrier frequency is Fc, am I not? Now this is the carrier C of t whose frequency is Fc. Therefore, now this spectrum is shifted right side as well as left side by an amount of Fc. Now that spectrum is shifted to right side. This is Fc. Now spectrum is shifted to right side Fc, and this is Fc plus 1 by Tb, and this is Fc minus 1 by Tb. And this is shifted right side and left side by an amount of Fc. Now this is shifted to minus Fc plus 1 by Tb and minus Fc minus 1 by Tb. This is the spectrum of spectrum of ASK signal, amplitude shift keying signal in frequency domain, spectrum of ASK. Now this is for S1 of t, but there is no negative frequencies, therefore you forget about this. Now what about S2 of t? S2 of t is nothing but 0. S2 of f is also 0. This is S2 of f, which is equal to 0. So not a problem. Okay. So finally, this is the spectrum of ASK signal for binary 1, for binary 0. Now there is a frequency ranges which is available. Now you tell me what is the bandwidth required to transmit an ASK signal. The bandwidth required to transmit an ASK signal is the bandwidth required to transmit an ASK signal fc plus 1 by tb minus of fc minus 1 by tb, fc cancel. Now 2 into 1 by tb, now inversely proportional to pulse width 1 by tb, which is nothing but rb, bitrate rb. So 2 into rb hertz. Now this is the bandwidth of ASK signal, twice of bitrate. 1 by tb is nothing but bitrate. Okay. So this is the bandwidth required to transmit an ASK signal. Then you can decide at the channel bandwidth and you go for the demodulation process. Okay. Note. Now, this is the story of amplitude shift keying. Now we will see the phase shift keying. Okay, PSK, phase shift keying. First, you tell me the definition. What is a PSK? Phase of the analog carrier is varied in accordance with binary data. Okay, phase of the analog carrier is varied in accordance with binary data is called as phase shift keying. Okay, so now first modulator designing. Now this is the message signal, which is nothing but binary data. But to generate a PSK signal, if you want to generate a PSK signal, phase is changing here. To generate a PSK signal, this binary data must and should represented in non-return to zero signaling scheme. Non-return to zero signaling. Now what is a non-return to zero? Non-return to zero means binary 1 is positive voltage, binary 0 is a negative voltage. Okay, this is called as non-return to zero signaling scheme. You know that. Okay, all are different schemes. Previous one is on-off scheme. On-off means binary 1 is positive voltage, binary 0 is 0 volts. But non-return to 0 means it will not go to 0 level, positive voltage or negative voltage. But depends upon the application. But for easy calculations part, binary 1 I am represented as plus 1 volts, binary 0 I am represented as minus 1 volts. Okay, this is a non-return to 0 signaling scheme. First we want to represent this. So a binary data is represented in non-return to 0 signaling scheme. Now this is the message signal, which is the binary data, but it is represented in non-return to 0 signaling scheme. Now for binary 1, this is the positive voltage. For binary 1, this is positive voltage. For binary 0, this is the negative voltage. For binary 1, this is a positive voltage. For binary 0, this is the negative. Okay, so this is 0 TB 2 TB. Right? Now this is a non-return to 0 signaling scheme for binary 1 positive voltage, binary 0 negative voltage. But this cannot able to transmit for the longer distance, then we'll take the help of carrier. will take the help of analog carrier AC cos 2 pi FCT. Now, what is this? Plus 1 volts multiplied with AC cos 2 pi FCT. This is S1 of t. Minus 1 volt multiplied with AC cos 2 pi FCT. This is S2 of t. Now, which is nothing but PSK signal. Is it right or not? Because now see here, this is the ASK PSK transmitter or modulator. Now let us check here. Now what is S1 of t? S1 of t, which is equal to plus 1 volt multiplied with AC cos 2 FCT plus AC cos 2 pi FCT. Next, AC cos 2 pi FCT multiplied with minus 1 volt. Therefore, this is nothing but minus AC cos 2 pi FCT. Or you can write like this. AC cos 2 pi FCT, AC cos 2 pi FCT plus 0 degrees. And this we can write like this, AC cos 2 pi FCT. Now this minus is nothing but 180 degrees plus 180 degrees. Okay. So now this is AC cos 2 pi FCT plus 0, AC cos 2 pi FCT plus 180 degrees. Peak amplitude is amplitude not changing, frequency is not changing, but there is a change of phase of 180 degrees. Therefore, this is called as phase shift keying. Okay, PSK signal. Okay, that's why I'm writing S1 and S2. This is the PSK transmitter or PSK modulator. Now we'll see the PSK waveforms in time domain. What is a PSK signal? Right, now you see here AC cos 2 FCT multiplied with plus 1 volts means AC cos 2 FCT. Now this is for AC cos 2 FCT multiplied with minus 1 volt. Now see here, this is S1 of t and this is S2 of t. This is S2 of t. Now this is for binary 1 and this is for binary 0. If you see this transition, now what is this? From binary 1 to binary 0, there is a phase shift of 180 degrees or not? There is a phase shift of 180 degrees. Now again for binary 0, if you want again it is a binary 1, again at this particular transition there is a phase shift of 180 degrees. Okay. So this is nothing but a PSK signal. In time domain we call it as PM. But if you observe or not, in analog signal now PM waves in time domain which we are not drawn, because that is analog continuous wave signal where exactly the phase changing is identification is somewhat difficult. But there is a transition here from binary 1 to binary 0. This is a transit from 1 to 0, 0 to 1, 1 to 0. So you can exactly identify at which particular location the phase is changing, at which particular point exactly the phase is changing. So this is the transit point where the phase is changing from 0 to 180 degrees. So there is a change in phase of 180 degrees between binary 1 and binary 0. Okay. Now that is a PSK signal in time domain. This is a PSK signal and this is a PSK modulator or PSK transmitter. And you know that what is a demodulator? The demodulator is nothing but this is PSK signal input to the receiver S1 of t and S2 of t. Now I am using the local oscillator will generate the same frequency and same phase of the carrier. Therefore, this is called as coherent detector. This is the PSK receiver or PSK demodulator. This is the PSK receiver or PSK demodulator. Okay, this is a PSK receiver or PSK demodulator first. Now this is a PSK receiver or PSK demodulator. Now we'll see what happened one by one. Now here, output of multiplayer at the receiver is S1 of t multiplied with AC cos 2 pi FCT. Right? S1 of t multiplied with AC cos 2 pi FCT. And one more thing is S2 of t multiplied with local oscillator signal AC cos 2 pi FCT. So what is the final answers here? AC square by 2 plus AC square by 2 into cos 2 pi into 2FC into t. Now what is here? Minus AC square by 2 minus AC square by 2 into cos 2 pi into 2FC into t. Okay. So output of the low pass filter will not allow this. So for S1 of t, this is plus AC square by 2. For S2 of t, this is minus AC square by 2. For S1 of t is plus AC square by 2. For S2 of t is minus AC square by 2. Now see here, for S1 of t, now this is plus AC square by 2. For S2 of t, this is, for S1 of t, this is plus AC square by 2. For S2 of t, this is minus AC square by 2. So this is the output of the demodulator. This is the output of the transmitter. So this is the output of the transmitter PSK signal and output of the demodulator. Your transmitting signal is 1 and 0. Your receiving signal is 1 and 0. Okay. Now this is PSK transmitter or modulator, and this is PSK receiver or demodulator, which is called as coherent detector or coherent demodulator. Okay.